Welcome to CAD with Mr. Hew. In today's video, we'll be looking at how do we bisect a given line AB. Then we'll be looking at how do we construct a 60-degree angle. We thank you for joining us, and at CAD with Mr. Hew, we aim to become your favorite AutoCAD resource online, and we thank you for joining us. We'll be starting the video now. Welcome to today's video. In the previous video, we looked at how we find the circumference given the diameter of a circle without the use of a calculator. Did you visit the video? If so, I would love to know your thoughts about the video. Alright, so in today's video, we will give the solutions. So the first question is, we'll be required to draw a line AB that is 30 millimeters long and bisect it. Alright? Now, do you recall how to bisect a given line? No? Yes? Alright, we'll see in a little while. Alright, we're gonna see the principles for the answer in the video today. Alright? Thanks for joining us. Welcome back to the channel. In today's video, we will bisecting a given line. Now, in the previous video, we looked at isometric projection. And in today's video, we are doing a different topic. All right, we're doing geometrical construction, and we're looking at how we bisect a given line. So here we have a line AB that is 300 millimeters long, and we're asked to bisect it, right? So the first thing we're going to do is draw the given line AB, which is 300 millimeters long. Sorry, so we're going to select our line, and this must be 300. Enter. All right, so here we have our given line AB, and the length is 300 millimeters long. All right, now what you're gonna let us label the line. All right, so here we have labeled the line AB, and what we're gonna do now, we're gonna draw an arc with center A. Right, so you would put your compass at A, and any radius greater than half the length of the line. Half the length of the line, you would mark an arc going around, okay? All right. Now we're gonna do the same thing at B, and would use the same radius, okay? So center B, radius equal to the same radius that you used before to draw the arc from A. Good. Where the two arcs intersect, you're gonna draw a line from the intersection. All right, so here's our bisector, and we're gonna label it now, okay? All right, so here we have labeled the bisector, and this line is a bisector. Now, when you're learning to draw, the first principle that they normally teach you is how to bisect a given line. So, just to recap, here we have a line AB, and it was 300 millimeters in length, right? What we did, we mark an arc with a radius greater than half the length of the line to give us this arc. Then, at B, the same radius, we mark an arc. Where the two arcs intersect, the line drawn through the intersection of the two arcs, that's a bisector. Okay? All right, let me show you how, let us label this line, right? Good. Then we're going to label it bisector. Right, so the bisector is a first principle that they teach in a drawing course. right? Such as a technical drawing course or a similar related course. And it is used to do many other different things, right? So if you have a triangle, for example, and you want to draw a circumscribed circle to the triangle, you would bisect any two sides of the triangle, and where the two bisectors intersect, that will be the center for the circle that would pass through the 3 points, um, 3 points on the corners of the triangle. All right, so there is a finished product or the finished drawing. Good job if you completed the drawing. And this brings us to the end of today's video. Thanks for watching. In the next video, as I had promised you in the previous video, we'll be looking at the um, conic section. All right. So good job if you follow the principles and you drew your drawing. Looking forward to seeing you in the next video. So take care until we meet again. Bye. Welcome back to the channel. In today's video, we'll be looking at geometrical construction. And specifically, we will be constructing a 60-degree angle. All right. So get your compass, get your T-square, get your set square, get your pencils. And we don't need a rubber because we're gonna draw accurately from the start, okay? All right, so here we have a line AB. It is 200 millimeters long. Well, the question says 300, but I drew mine 200 millimeters. All right, it's the same principle. And for 2, we're going to construct an angle of 60 degrees. So, you know that this should be labeled the other way, right? So let's fix it. This should be it should say C, B. Isn't that correct? Right? Is that correct now? Right. So this angle is labeled CAB. Okay? So note the correction. And also, there should be a tilde, like a ups inverted V above A. All right? So please make note of that. All right? All right, so the first thing we're going to do, we're going to draw our given line. And the line that I'm drawing today is 200 millimeters versus the 300 millimeters that I wrote in the question. All right, is that fair enough? Good. So you can draw yours either 200 or 300. It doesn't matter. So mine will be 200. Enter. All right. Now, let me label A and B, okay? All right, so I've labeled the line AB so that you can follow. All right, so what I'm going to do now, I'm going to construct the angle CAB, which is this angle here, this angle. We're going to construct it. So get your compass, all right? So get your compass. You're going to put the compass point at A, and the radius can be any radius, all right? But I'm going to make mine radius 40 millimeters. I don't need to measure the radius, okay? All right, so right, you don't need to measure the radius, but I'm going to make mine 40 millimeters. All right, so here we go now. You're going to put your compass at A. Any radius that's convenient must be too large or too small. So the radius couldn't be 150 millimeters. It would look out of proportion. All right, the construction will look out of proportion. So we're going to scribe our arc. So our pencil is going to make an arc. Now it doesn't have to go all the way up there because the 60 degree, as you can see, would be somewhere here. All right? All right. So we're going to come again. The same radius that you put your compass to your mark, you're going to put it at the intersection of this point. Right? I use 40, so you have to use about the same radius. Enter. All right, so watch now. Here. See that? So the line drawn from A going through the intersection of these two arcs, that is where the 60-degree would be. That's a common geometrical construction in math, technical drawing, or engineering graphics. All right. So we're gonna go line. So the compass must be at the same radius. Okay. Enter. All right. Here I've labeled the angle C. Right. How can I prove to you that it is an accurate geometrical construction? Can you guess? Pause the video and then come back for about one. All right, so here I've labeled the diagram for completeness. So D, so the first step you would have open your compass, your geometry set compass to any radius that is convenient. So you couldn't open it to 5 mm because you wouldn't be able to adjust the compass to it would be the radius would be too small. Understand? So you would open your compass to any convenient radius, maybe about if the line is 200, then 40 mm is a good radius. But 20 mm could work too. You would scribe this arc where the arc intersects this baseline AB at D. You would use the same radius of 40 mm if you use 40 to scribe an arc to give you this arc. Where the arc intersects the previous arc at E, that the line drawn from A through E and extended up to C would give you the 60-degree angle to AB. So here my computer measured it, and this is a construction for a 60-degree. It's a standard construction in any geometrical construction, right? So you have math or technical drawing is the same fundamental principle used to construct a 60-degree angle using your geometry set instruments, right? So in today's video, we looked at how you construct a 60-degree angle using the geometry set compass or in AutoCAD, right? And it's a fundamental construction, as we said, using math and in physics. If you're doing a forces diagram, right, and you're doing it graphically, meaning maybe on a graph paper or on a folder paper with geometry set, you could use this method. Also, if you are doing building and mechanical engineer drawing, which is a sixth form program, a CAPE program, Caribbean based program, or a different type of program where you're doing forces, calculation of forces and bending moments and shear force diagram. If you have a 60-degree angle of a force being applied and you're doing it graphically, meaning you're drawing the solution with a t-square, set square, and compass, you could choose to construct the angle like this, or you could use a protractor that is in the geometry set, right? But if you are doing geometrical construction, this is how you would construct it using your compass, t-square, and set square and pencils, all right? So this brings us to the end of today's video. So in today's video, we looked at the fundamental principles of constructing a 60-degree angle. I hope you found the information useful. If you found the information useful, then perhaps you could subscribe, press the notification bell, click the like button, share and subscribe, and or comment. And take care until we meet again. And we look forward to seeing you in the next video. Bye. We have come to the end of today's video. In today's video, we bisected a given line AB. We constructed a 60-degree angle to a line AB at A on the line. And in the next video, we'll be showing you how to bisect a given angle. So we look forward to seeing you in the next video, video 5. Please take care until we meet again. Bye.